Okay, so let's go to presentation mode. Okay, factor by grouping. This kind of is the next step after you have looked for GCF. So I'm going to go ahead and remind you about GCF, greatest common factor, or you could think of what can I divide out of every single term. Okay, so I have a little binomial here, and I'm going to try to divide out the most I can. What is the GCF? Okay, so 1 and 9 are factors of 9, and 3 and 3. And then for 30, 1 and 30, and 2 and 15, and 3 and 10. 4, no, not divisible. 5 and 6, and that's all. Now, which is the largest, greatest number that they have in common? 3. Okay. And then we have x to the third and x to the first. So the most I can take out is just 1x, because this guy, that's all he has to take out. So that is my GCF. But then when I'm factoring, I'm going to have 3x out here. And this is going to show you the entire factorized form. Okay, factorized form. So I take this out, I've got 3x squared left over. When I divide this out of here, I get 3x squared left over. There's a plus sign here, so a plus sign there. 30x divided by 3x is going to just be plus 10. So I used up the x when I divided it out. Okay, so this is our final answer here. Now, looking at this problem, this is a trinomial, and I'm looking for what is the GCF so that I could show you the factorized form of this. Okay, so I divide by what? Well, 2 is the largest thing I can divide out. Now look at the variables. I've got 1y, so can I divide out any x's? Well, this guy's got 2, this guy's got 1, this guy's got none. So no, I can't take any x's, but I can take some y's because they all three have y's. And this one is limited by 1y. So I'm going to take that out of this is always going to be the same number. And it's like we're dividing it out. It's called factoring it out. So I have 2y on the outside. Now remember, this is the GCF. And then the whole thing is called the factored form. Or it's factorized. Okay, so we got 12 x squared, and I used up the y. Then positive 18 divided by 2 is 9. There can't take out this x, so the x is left, and only can take out 1y. And then a lot of people would want to end it right here and say, oh, well, this turns into nothing. No, this turns into negative right here. When something is over itself, that just equals 1, right? So if you had 5 over 5, you would say that equals 1. Well, 1 is not nothing, right? Okay, so here's our final answer. Now that's a reminder of GCF. Okay, so what is the GCF of this? Well, at first you might be thinking 4, right? Because these are both divisible by 4, but that's not. So correct answer would be 2C, which is answer choice C. Okay, now here are the steps for factoring polynomials by grouping. So this is the new idea, factor by grouping. This is when you have 4 terms, and what you're going to do is you look to see, hey, can I factor out one thing out of all 4 of those? No, there's not one thing you can take, but if I was just looking at these 2, what could I factor out? How about an x squared? Okay, so then we end up with x squared, and what we left behind was an x and a positive 7. Well, what can I divide out of just these 2? Well, they're both divisible by 2. So a positive 2 is what we're dividing out or factoring out, and we're left with x plus 7. Oh my goodness, look at that. Twins, it's a miracle. We get the same thing here and here. Okay, that's what we want. That's what tells us we're doing it right. So we take one of those twins. one of those binomials that appeared twice. And then we take the leftovers. We take the x squared plus 2. And now we have two binomials that when they multiply together, they equal this. So when we take the product and we break it down to the factors, that's called factoring. Now you can remember from last week that you can use the rainbow method or FOIL or the box method. Let's just check our answer. So this is the answer. Now we're going to check our answer. So I use rainbow. I multiply first term times this. I got x to the third, then x squared plus 7, so 7x squared. And then 2 times x is a positive 2x. And then I've got 2 times 7, that's a positive 4. Well, look at that. I came back with the same answer. Okay, so this is correct. But our answer for factoring was this. Okay. Now, here's a couple more examples. I'm going to have 4 examples altogether. So you can put a line here if you want to. Some people like to do that, so they remind themselves, I'm just trying to factor the most I can out of these. So at least a 3, and then look, this has got x to the third and this has got x squared. You can factor out an x squared here. If you don't factor out the most you can, then you're not going to get those twins, and you're not going to have it factored correctly. Okay, so now I'm left with just an x. Oh wait, I got to write the greatest common factor of those 2 is 3x squared, so I write that on the outside. Then x plus 5, and that's my answer. Now, I need to get this same thing over on this side. Remember, I'm looking for twins. So if I want it to be x plus 5, what should I divide out of this? Well, not just a positive 2, right? If you divided positive 2, you'd have negative x. You need to divide by negative 2. And just as a little hint, anytime you see a negative here, you should be dividing by a negative here, okay? And so that gives us minus 2, or negative 2 is what we're dividing out of both terms. And then we have x plus 5. Oh, good. Now I've got these twins. The same thing appeared twice. That's how you know you're doing it right. And at this step, you might ask yourself, hey, this is still an x squared. Is this a special? A special, remember, is when you have 2 perfect squares here, and then that can be, and there's a minus in the middle, then you can continue factoring, right? So this is an example of a special, plus and a minus, and a 2 and a 2. It's when we take the perfect square of both the first term and the last term, and we have a plus and a minus in the middle. Well, this is what we studied last week. We FOILed this and got this. Okay, but this is not a special, so we're just done. This is our finished answer. Okay, now what about this one? So just look at the first 2 terms and see what you could divide out. At least a 2, and then, oh, this has an x and a y. This has an x and a y as well. So I'm going to divide out the most I can. Now, 2xy, that's my GCF. And then what is left over? We've got an x, that's it, plus 3. Okay, x plus 3. So I want to divide whatever I have to out of this to get that twin, that x plus 3. So what could I divide out? Well, there's no numbers I can divide out, but I want this to be a positive x, right? So I'm going to divide out a negative 1. So I make sure to put negative 1 right here. And then that's going to give me x plus 3. Oh, good. Oh, good. So now I have 2xy minus 1. I take the leftovers and I put them as one binomial. And then I take one of those twins and use it, okay? Some people think they get crazy and they start writing this on there too and say, oh, there's 3 factors. No. That's not how it works. Don't do that. Okay, so this is our final answer. You only write that twin one time. Excuse me. And going on. Okay, so what can I divide out of both of these? Oh, wait, I think I still need to go to another slide. There we go. All right, what can I divide out of the first two terms? Well, you see that they're both, and this is another way to do this. Sometimes people write it like this. They just put one big line and they say, I know I can divide out 3 and a y. Do you see how that's different? How I was writing it before with the numbers on it? It doesn't matter. It's just another way to show your work. Okay, so 3y is my GCF. And then I'm dividing out 2 and a y is left over. Minus, okay, these two things are the same. So when you have the same thing, it's still going to be a 1. Okay, so now that's the twin that I'm looking for. And in order to get that twin, what is the only thing I can divide out? Oh yeah, I was going to do it this way. What can I divide out of both of those terms? A z. Okay, so and it's a positive z because I want this to be a positive 2y. So I say plus z, and then 2y is left over, minus 1. Oh, good. That's great. I got my twins. I know I'm doing it right. I'm going to use one of those as a binomial, and then, almost couldn't fit that in there. And then one more as the binomial. Now, just in case you're wondering, if you wrote this in the opposite order, that is still correct. Both of those are correct. They're just, remember, it's multiplication between them, and multiplication doesn't have any particular order that makes it right or wrong. Okay, now we've got our last set here. And first you might think of this and say, hey, I can divide both of those by 2, but there's a bigger number. If you divide by 2, you're going to get it wrong because you're not going to get the twins. Okay, so you divide by the largest number you can, which is 4, and an x. And so now I have 4x on the outside, and I have 2x plus 3. Okay, see I'm dividing both of those terms by this. And I show it this way. I got my GCF, and then what's left of the factorization. And then I got to get a twin, right? I've got to have 2 of these binomials that are matching. And so I'm going to divide this by just a y. That's the only thing those two have in common. So plus y. Now I want to make sure that you see this too. This is really important. If I were to write it this way, y, nothing here, just y, and then write 2x plus 3. Okay, there's something's wrong with this. Sad face. This is not correct, okay? Because that makes it look like you are multiplying all of these things together. You are not doing that. If you multiplied all these things together, you would not get back this. And that is incorrect. Not good. So let's fix it. And how do we do that? A positive y. Okay, so now I have 4x plus y. That's one of my terms. And then 2x plus 3. And I only use this one time, right? And so final answer. And one more. You are going to divide out, I don't know if you even need this one more, divide out the most you can from the first term, the most you can from the second term. See how I'm kind of like shortening all the writing as we go each step? X squared plus 4 is going to give me, this is the super short form of this. Okay, that's the shortest I would accept for shown work, okay? And it is true, this is factual, but you could easily skip a step and make a mistake. So just be careful about that. And that is factor by grouping.